Hello and welcome back. In this section, we're going to learn about atoms, ions, isotopes, and the periodic table. So let's start off with atoms. We've already given the definition of atoms, that they're basically the building blocks that everything is made up of. So now we're going to look at the structure of the atom. An atom is made up of protons, neutrons, and electrons. The protons and the neutrons are inside of the nucleus, and the electrons circle around the nucleus. Electrons are negatively charged, protons are positively charged, and neutrons have no charge in them. Remember that most of the mass of the atom is from the protons and neutrons that have almost the same weight, and the electrons are much less massive. They're about 1/2000th the mass of a proton or a neutron. So they don't contribute much to the mass of the atom, but they do contribute a lot to the volume of the atom. The electrons take up most of the space of the atom. The nucleus is very, very small relative to the rest of the atom. So like we said, protons are positively charged, and they're located in the nucleus, and they have mass. Neutrons are neutral, they're in the nucleus, and they have mass. Electrons are negatively charged, they're outside of the nucleus, and they have very little mass. Now we're going to talk about ions. Ions are atoms that have lost or gained electrons. So atoms on the periodic table like to either lose or gain electrons so that they can become more stable. Cations are positively charged ions. This results from them losing electrons. So they are positively charged because they contain more protons than electrons. So remember that protons are positively charged, electrons are negatively charged. If we have less electrons than protons, then overall the ion is going to have a positive charge, because as a neutral atom, it started off with protons and electrons being equal to each other. Anions are negatively charged ion, and they result from gain of electrons. So when there is more electrons than protons, because electrons have been gained, the overall charge is negative because there's more negative than positive. So that's as a result of more electrons than protons being present. So what we see here is that a neutral atom contains the same number of protons as electrons, and so that's why it has a charge of 0. If it loses an electron, or more than one electrons, then there'll be more positives than negatives. So overall, it'll have a positive charge. But if it gains an electron, then there are more negatives than positives. And so overall, it'll have a negative charge. A good way to remember this is that a cation has a T in it. You can think of the T as a plus sign. So cations are positively charged, right? So this kind of looks like a T, the plus charge, for cations. Now we're going to look at why atoms lose or gain electrons. So atoms lose or gain electrons so that they can achieve the electron configuration or the electron arrangement of the noble gases. These over here are the noble gases. Their electron arrangements are very stable. So the noble gases do not like to react. And that's one reason why they're called the inert gases, is because they're unreactive. So all the other elements on the periodic table want to be like the noble gases and have the same number of electrons as the nearest noble gas. So for example, lithium has 3 electrons. The nearest noble gas to it has 2 electrons. That's lithium, right? It's the top number here. So lithium likes to lose 1 electron. And that's actually true for all of the elements or all of the atoms that are in this group 1A, called the alkali metals. They all like to lose 1 electron because the nearest noble gas to them has 1 less electron than they do. So Na, for example, is sodium. It has 11 electrons. If it loses 1 electron, it'll have 10 like neon. So sodium likes to lose 1 electron. K, potassium, has 19 electrons. If it loses 1, it'll be like argon with 18 electrons. And that's true for everything in this group 1A. They like to lose 1 electron. Group 2A, which are called the alkaline earth metals, they like to lose 2 electrons because the nearest noble gas to them has 2 less electrons than they do. So for example, Be is beryllium. The nearest noble gas to it is helium with 2, right? Because the next noble gas is 10. So going from 4 to 10, that's gaining 6 electrons. That's not very easy. It's easier to lose 2 than to gain 6. And so this group 2A metals like to lose 2 electrons so that they can be like the nearest noble gas. Magnesium has 12. If it loses 2, it'll be like neon with 10. Calcium has 20. If it loses 2 electrons, it'll have 18, just like its nearest noble gas, argon. Strontium has 38. If it loses 2, it'll have 36, like krypton, Kr. Okay. This group over here likes to lose 3 electrons. And we're not going to really look at boron so much because boron is a special case, but aluminum and the other metals in this group like to lose 3 electrons. Aluminum has 13 electrons. If it loses 3, it'll be like neon, which has 10. And then group 4A is a little bit different, specifically carbon. Carbon doesn't really like to gain or lose any electrons because it has 4. So we're not really going to look so much at group 4A, but group 5A, these like to gain electrons. They like to gain 3 electrons because the noble gas closest to them has 3 more electrons. Okay. And then this group here likes to gain 2 electrons because the nearest noble gas has 2 more electrons than they do. And this group, the halogens, like to gain 1 electron. So fluorine, for example, would rather gain 1 electron and have 10 electrons like neon than to lose 7 and be like helium. So the nearest noble gas to them has 1 more electron than they do, so they will gain 1 electron. We're not going to worry about this middle group here, okay, or the group down here. These are called the transition metals and the intertransition metals. We're just going to look at the other groups called the main group elements. So the first 2 groups and the last 6. So why do atoms want to be like the noble gases? So why do the noble gases have this stability that everything else on the periodic table wants to achieve? Well, noble gases are stable because they have a full outer shell. That full outer shell could mean either 2 valence electrons, which is just for helium, or 8 valence electrons for the rest of them. Valence electrons are these outermost electrons. They are the electrons in this outermost shell. For helium, which only has 2 electrons, it only has 2 valence electrons. Neon, on the other hand, has 10 electrons. It will put 2 electrons in the first orbit, 8 electrons in the second orbit, so it has 8 valence electrons. Okay. Argon also has 8 valence electrons in its outermost shell. Argon has 18 electrons. 2 go in the first, 8 go in the second, and another 8 go in the third, so it has 8 valence electrons. Okay, so just note that except for helium, all the other noble gases have 8 valence electrons, and that's what all the other elements on the table want to achieve. So let's look at why they want to be like the noble gases and gain and lose, or how that happens. So sodium, we said, has 11 protons, and as a neutral atom, it has 11 electrons. So overall, its charge is 0. It has 1 valence electrons because we put 2 electrons in the first orbit, 8 electrons in the second orbit, so the 11th electron of sodium is in the third orbit and it's all alone. If sodium loses that 1 electron, then the next orbit will be now the valence shell or the valence orbit, and it'll have 8 valence electrons in it. So sodium loses that 1 electron, and so now it has the same electron configuration or the same arrangement of electrons with 8 valence electrons in the outer shell, just like neon. The difference is that sodium has 11 protons, neon has 10 protons. And so that's why sodium has a charge of +1. So sodium with a +1 charge and neon have the same electron arrangement. And that results from Na losing 1 electron. Now let's look at fluorine on the other hand. Fluorine has a total of 9 electrons, right, when it's neutral as an atom, and it has a total of 9 protons in the nucleus. It has 2 electrons in this first shell and 7 electrons in this outer valence shell. In order to have a full shell, it needs 8 electrons. It needs to gain 1 electron so that it can have 8 valence electrons. So fluorine gains 1 electron. It becomes F- and gets the same electron arrangement as neon. Notice that it still has the 9 protons, but now because it has gained 1 electron, it has 10 electrons, so the overall charge is -1. But now this F-, fluorine with a -1 charge, is stable, just like neon. So F-, neon, and Na+ all have 8 valence electrons, and all of them have the same electron arrangement. The difference between them is the number of protons that are in the nucleus. So again, on the periodic table, the elements either gain or lose electrons so that they can have the same electron arrangement as the noble gases. Notice that these on the left side like to lose electrons, and then the ones on the right side like to gain electrons to become like the nearest noble gas. So here on this periodic table, I'm showing you where the metals, the nonmetals, and the metalloids are. The metals are colored in blue, and they are on the left side of the periodic table. Notice that most of the elements on the periodic table are metals. Metals like to lose electrons, and we've seen already that the reason they like to lose electrons is so that they can be like the noble gases closest to them. We didn't really talk about these transition and intertransition metals, these in the middle, but they also like to be like the nearest noble gas by gaining or losing electrons. On the right side of the periodic table, we have the nonmetals. The nonmetals like to lose or like to gain electrons to be like the nearest noble gas. And in fact, the noble gases are also considered nonmetals. And then we have 7 metalloids that are here shown in pink. And if you can see this zigzag line over here, 5 of those 7 metalloids are to the right of the zigzag line, directly to the right of the zigzag line. So you just have to remember that these 2 other metalloids, Ge and Sp, are to the left of the zigzag line. And that's how we get the 7 metalloids. If you can remember these 7 metalloids, you just have to know that everything to the left of it is a metal, everything to the right of it is a nonmetal. So next we're going to talk about isotopes. Isotopes are atoms with the same number of protons but different number of neutrons. Isotopes belong to the same element because their number of protons are the same. So the number of protons determines what type of an element it is. So here we have 2 protons, and here we have 2 protons, because these both have 2 protons, each have 2 protons, they are both helium atoms. The difference between them is that this one over here only has 1 neutron, whereas this one over here has 2 neutrons in it. So these 2 helium atoms are isotopes of one another. They have different masses. The one that has more neutrons is heavier than the one that has less neutrons, but they both still belong to the same element, helium. So now we're going to look at isotope symbols. There's 2 different notations that we use to show the different types of isotopes in an atom. Let's look at the first notation. So the first notation has A on top, Z on bottom, and an X next to it. So first let's look at what Z, A, and X are. Z is called the atomic number, which is another name for the number of protons. So we just saw that for helium, for example, which has 2 protons, its atomic number, or the Z value, is 2. Okay. A is called the mass number. The mass number is the number of protons plus the number of neutrons. Of course, an isotope with more neutrons in it will have a greater mass number. And then the X is the element symbol. So here's an example. I'm showing you calcium. Calcium contains 20 protons. So anytime this symbol here is calcium, this number here at the bottom left has to be 20 because it's the 20 that defines that this element is a calcium. On the top here, I have the charge of calcium. So if I were to calculate the electrons, I would know that this has 2 more protons than electrons. So it contains 18 electrons in it since the charge is plus 2. Okay. It has a mass number of 41, which means that the protons plus the neutrons is 41. So if I subtract the A by the Z, so 41 minus 20, that gives me 21, and that's the amount of neons, the number of neutrons that it has. So the mass number minus the atomic number is equal to the number of neutrons, which makes sense because the mass number is the protons plus the neutrons, the atomic number is the protons. So if I subtract the atomic number, then these 2 cancel out, and that leaves me with the number of neutrons. In the second notation, we have the element symbol dash atomic number. Notice that up here in this first notation, it's kind of redundant to have the atomic number and the symbol. Because if we know the symbol, we can just easily look up the element and see how many protons it has. So we don't need to give both the atomic number and the element symbol. And that's what the second notation does. The second notation leaves out the element's atomic number, the atom's atomic number. So here, for example, we have calcium 2 plus dash 41. Notice that I left out the Z, the 20, because the calcium symbol tells me that there are 20 protons present. I could just look that up on the periodic table. Again, I know that there are 18 electrons since the charge is plus 2, right? That means there's 2 more protons than electrons. So there's 18 electrons if there's 20 protons. And since the mass number is 41, 41 minus the number of protons, which is 20, gives me 21, which is the number of neutrons. All right, so that's the end of this lesson. Here's some practice problems for you to solve. You can just pause the video, solve these problems on your own, and then on the next slide is the answers to these problems. And here are the answers to the problems on the previous slide.